In this lab video, I'm going to go over the calculations for experiment 10, part 3, our Beyond Labs experiment. I have sample data here. So the mass of KHP you weigh out with the Beyond Labs experiment. And remember, you want to record every single digit that is displayed in that digital scale. So this is different from what we have in our face-to-face labs. We actually have 4 digits past the decimal point. And you perform titrations, and you need to make sure you record the initial volume. So for my first titration, the volume was about halfway between the 0 and the 0.1 on my burette, so I called that 0.05 milliliters. And I titrated until light pink, my final volume being a little bit below the 19.1, looked about 19.12 to me, and again, units of milliliters. Our goal is to get the molarity of our NaOH, which we solve for by calculating first the moles of NaOH, then the liters of NaOH added, and then we're going to divide. The first thing we're going to do is find the moles of NaOH that were neutralized. And we do that by starting with our mass of KHP. And the KHP, the entire chemical formula, KHC8H4O4. I'm going to convert to moles of KHC8H4O4 because once I figure out the moles of KHP, I know from my balanced chemical equation, for every 1 mole of KHP, I've got 1 mole of NaOH. And then that allows me to go to moles of NaOH. Again, we convert from grams to moles using molar mass from the periodic table of the potassium, 5 hydrogens, 8 carbons, and 4 oxygens. We can convert from moles of KHP to moles of NaOH using our mole ratio from our balanced chemical equation. So I'm going to start with my 1.2454 grams of KHC8H4O4, and I need units of grams downstairs to cancel, moles upstairs, and a molar mass for every 1 mole of KHC8H4O4. The mass we solve for in our pre-lab of this experiment, 204.22 grams. So I can see my grams of KHP cancel. And now I need to convert to moles of NaOH. So I need moles of KHC8H4O4 downstairs and moles of NaOH upstairs. And these numbers, it is a 1-to-1 mole ratio because in our balanced chemical equation, we have a 1-to-1 mole ratio there. So that's where those numbers come from. Moles of KHP cancel. We're left with moles of NaOH, so what we want. So on the calculator, we're going to type in 1.2454 divided by 204.22, enter. So 1.2454 divided by 204.22. So we're going to ignoring the multiplying by 1, multiply by 1, divide by 1, because that will not change our answer numerically. And I end up with 0.006098325 moles of NaOH. Thinking about sig figs, 1, 2, 3, 4, 5. I've got 5 sig figs. 5 sig figs, and my 1-to-1 mole ratio unlimited. So I need 1, 2, 3, 4, 5 sig figs there. And I'm going to go ahead and round at the end. So I'm just making a note that I've got 5 sig figs. My next step, calculate or find the liters of NaOH added. I know my burette started at 0.05, ended at 19.12 milliliters. So we can find the liters added. You always, anytime you're adding something from a burette, V final minus V initial, 19.12 milliliters minus 0.05 milliliters equals 19.07 milliliters of NaOH. And we can convert to liters by dividing by 1,000. I know that 1 liter contains 1,000 milliliters. Double checking that our units cancel, which they do. 0.01907 liters NaOH. So I've got the liters of NaOH, I've got the moles of NaOH. Step 3, we can solve for molarity of NaOH by dividing. 0.006098325 moles NaOH, 1, 2, 3, 4, 5 sig figs, divided by 0.01907 liters, 0.01907, which gives me 0.319786 molar NaOH. And I add 4 sig figs from my moles, 5 sig figs from my moles, 4 sig figs from my liters. So I need to have 4 sig figs from my molarity. Okay, so this is an example of how to find the molarity of NaOH for one trial. You will need to do this for trial 1, 2, and 3. You're going to want to make sure that the molarities are within 0.002 of each other. So you'll take the largest molarity and the smallest molarity of your trials and you'll subtract them. And you want the answer to be 0.002 or less. If it's greater than 0.002, you want to go ahead and perform additional titrations until you have 3 titrations whose molarities are within 0.002 of each other. So just referring back to the calculations for part 3, again, we looked at the roadmap. For each trial, you're going to get the molarity of NaOH. We talked about making sure your numbers are reproducible. So for number 3, I really want to see you writing this down. So you'd have your largest value. So let's say my largest value, for example, is 0.3018 molar. My smallest value maybe is 0.3016 molar. And when I subtract the two, I get 0.0002 molar, which is indeed less than 0.002. That's good. Step 4, your average. So you would have your 3 best values. Maybe we did it with molarity 1, molarity 2, and maybe it was molarity 4. You had to redo it again. Add those up, divide by 3 to get an average. And so we need to keep those 4 significant figures. Okay, hopefully this will help you with these calculations.